Good morning, everybody. How are you? Today we'll talk about the last unit in our course for this curriculum. We'll talk about logarithmic equations. How do we need logs? Where we get them from? Before we start talking about rules, let me give you something you already know. Remember when you have an equation like this? How we used to solve it? We used to add -2 to both sides and x equals 3. This is one method this is one skill you have to solve. How about when you see a question like that? How can I find x? So what do? You take square of both sides. And what happens? When you square, the square root will be x, and 4 squared is 16. And remember in the last topic we did chapter 8, how we used to solve something like that. We said it's an exponential equation. The best way to go for basic exponential is to put them both, hopefully, to have the same base. Because once the same base are equal, then you equal the power and x equals 3. All of these were different skills to solve equations. All right? Now, today we'll talk about what happens if the exponential function or the exponential equation has a 5 or 3 or 2 or 8, whatever. Can I make this an exponential equation? I can never write this exactly to the power of something that will all give me 5. I can't. Yes, the number you put here simply is called an irrational number. This irrational number, not exact. You have to keep trying for like 10 hours to try it, except if you use something nice. This we call using logs. The shortcut for logarithm is log. Either you write it like this, or you write it like that. LG or LLG. So, since we cannot do it that way, what's the idea behind it? Let me first define some basic things. What do we define this? A base. Remember that. And what do we define this? A power, an exponent, an index, whatever. And let me define this, the answer. I don't want to go that advanced. I just want to make sure that you see the easy way. This is called an equation. And this equation, it comes in the exponential form. This equation is written in the exponential form. I want to have a little idea. If I can convert that equation from exponential to logarithmic form, then I'm very happy now. How? Introduce log. It has a base here, the same base, so nothing new. Reverse those two. I'm done. Go to your calculator and find the answer. And as simple as that, there's nothing harder than this. So I'm going to go to a button in your calculator. So your x in this situation, simply it is what? It's a log 5 to base 2. Look, you are writing everything on one line. Don't write the 5 as a power. Don't bring the 5 down to the 2. Don't bring the 2 here. Or maybe there. This is the wrong way of writing things down. If you want to write it properly, at the end of the tail, somewhere here you can put the 2. How do we say that? This is called log 5 to base 2. It has a number, it has an answer. This answer can never be exact. I'm going to press at this button in my calculator. This is my calculator. This is the screen. There's a button here under the on. This button. What is that button called? Log, something black like this, and something like that. So your job is to press it, put the 2 first, move the cursor, push it, it will come to 5. It will open a bracket like this, okay? And the bracket, and then get out, make the blinking out, then say equal. So if I'm going to put log 2, and here's 5, the answer is what? The answer in this case, it's not exact as I said, and you would have said, let's round it to 2 decimal places. So if you mastered that little skill, you technically solved 80% of the topic, because you need to use it. The problem is some people do not know how to use it. So this chapter simply talks about how to use logarithms to solve equations that cannot be solved in the normal traditional method. Let's take some more examples. Number 2. 3 to the power of x equals 7.5. No way. So what I do, I introduce log. This is my base. Switch those. Go to your calculator, and your calculator will do you the job right. You can leave it like that. That's called the exact form. You can use the calculator. I have no problem. All right. How about this one? Number 3. 10 to the power of x equals negative 2. So I'm going to introduce log. I'm going to leave the 10 there. I will switch. The answer is x. First of all, why don't I stay without the negative first? I know there's no answer for that. Let's stay without the negative for the meantime, because the log is defined only when this number is above 0, as well as this one. All right? So you can have here half, but you cannot have a negative number here. You cannot have a 0. So, oh, by the way, another new information, good information. Remember square root of x? Do we have to write like this? No. It's enough to write without this. This is called the default. That's why with your calculator, there's a button for that. And if anything else, there is another thing that's for everything. Like cubic root, 4th root, 5th root, 6th root, 10th root, 100th root, whatever. The same thing in logs. You can write this log without the 10. Why? The default only will have a 10. So whenever you don't see anything here, it means 10. Go to your calculator. There's another button below that button. Okay, next to the len. There are 2 buttons in your calculator. واحد اسمه log والثاني اسمه len. This log base 10. So go here, 2, and the answer is 0. If you wish, 699, or you can say roughly 0.7. All right. 3. I'm trying to put all the rules you need in a way of solving questions, and I think that's a smart idea. I don't know if you like it or not. Let's look at number 4. You all know what's E. You don't? Yes, I do. Go to your calculator. Shift len 1. So I'm trying to put this in the calculator. I want to know what is this number. Oh, this is not exact. 1828, 1828, 182. This is a rational number. Cannot stop. That's not a fraction. All right? It's not even like pi, because pi 3.14159, or you can write it like 22/7. In a way, it can be rational. In a way, it cannot be rational. But that one, no. So this E, if I say, let me give you a question. E to the power 3x equals 2. I'm putting something in x. I can put 3x plus 2. I can put 3x plus 5. I can put this power of x squared. I can put square root. I can put anything there. You learned this from chapter 8 exponential function. Let's turn this into log. Remember, E is like a number. All the numbers we know it on earth are called real number. So that's a real number. So I'm going to introduce the log. This is the base. Switch those. I can divide both sides by 3. Why? Because I'm good in algebra. All right? So the final answer, I can put it like this. X equals log 2 to base E. Maybe I should write it nicely. I keep some space here. Log 2 to base E. And there's a 3 here. I can write it like 1/3. Let me tell you something is good to watch out. Something nice. The log to base e, this can be written the natural logarithm of 2. So only whenever you see base e, all of this, simply called len, the natural logarithm. Don't forget the 3. I did not forget. You can go to your calculator. Yes, you can. Why not? Let's find out. This is my log. Next to the log, there is something called ln, len. Len 2 divided by 3. 0.231. And that's x. So, what have we learned in here? We've learned many things that you did not notice. First, we said log to base 10, we don't have to write the 10. Then we also said log to base e, we can write instead of that len. All right, and we also said that there's a basic rule: a to the power of x equals b or y or c or b or a. If you want, you can put it all letters. I can go backward or forward using the exponential form and turn it into logarithmic form, keeping in mind a is the same, and switch the b and c. I would like to call this basic rule. You want to call it something else? Sure. You name it. You know why I call it basic rule? It works backward and forward. What do I mean? Let's take another example. Number 5. What's log x to base 3 equals minus 1? Now I'm giving you logarithmic equation. I'm asking you to solve it. You gotta go back to exponential form. You gotta make this equation from logarithmic back to exponential form. معادلة لوغاريتمية، معادلة أسية. معادلة means equation because there's an equal here. So what do we do, guys? Get rid of the log. Make the 3 as the base because it was base. Keep it as a base. And switch those. What do you mean 3 to the power minus 1? It means 1 over 3 to the power 1. And that's the answer. No need to say 0.3333, whatever. See? I'm trying to use all the knowledge I've learned today. How about number 6? Len x minus 2 equals 3. Oh my God, len. Why no, len is actually log. So I can rewrite it like this. Log x minus 2 to base e equals 3. I know some teachers, some people, some books, they have different approach to this question. I'm having one approach so far. I can show you how to solve this equation in another way. No problem. In a minute. This is the base. Switch those. Ta-da! Now I want x. X is positive. Leave it. So e to the power 3 plus 2. You can even leave it like that. Especially electrical and mechanical, they love these exact things because it makes a big difference when you round things. It's not like money. So shift len 3 plus 2. The answer is 22.1, roughly. All right, it's 0.8555. So let's say 0.1. Can I make these questions hard? It's no point to make it hard if you don't know the game. So what is the game? This is your baby. It's better to make sure that you can grow your baby correctly. What do I mean? Use the same rule. Some people, they may go to the net and find another way of solving it. Let's go back to the first equation we did. What was it? Who remembered that? I think that was it, what we started with, wasn't it? Yes, we did. I can approach it a different way. Instead of playing this thing that some people don't like it. I can take log to both sides. Look at the approach and look how long is it. Is it good or nice? I don't know. What I did now, I took log to both sides. The same thing you studied before. When I have x squared equals 9, what do? I take square root to both sides. Don't forget the plus or minus. The same idea. I am taking the log to both sides. Now there's something you have to realize. The x as a power gotta go out. That's a rule, my dear. So what do we do? X log 2 equals log 5 times. You need these ideas when you go to math 2, by the way. A lot. I want to get rid of whatever next to the x because that's the equation I do. Remember we have a question like this? 2x equals 5. How do we solve it? Divide both sides by 2. I didn't do anything new. Simple like that. Divide both sides by log 2. And guess what? What do you see? We can see log 5 divided by log 2. And guess what? What are the bases for each one of those? The question, are they the same? Yes. Same to what? To 10. But I just don't have to write it down. Yes, you don't have to write it down. Yes, you're right. But if I put base 6, I put base 6. So here, when I took log to both sides, I meant log of base 10. Unless I want to take log to base 7. Both. Unless I want to take log to base 5 million, 5 million. It doesn't matter. But you know why? Because there's another rule here. If you were to join those two into one thing, you can write it like this. Log 5 to base 2 as far as the bases are the same. Now, we end up with the same thing. Remember how we solved that question? No, you don't remember. Why? Because you are watching the movie and you're not focusing. Remember when I solved that question like this? I said, let's use the rule. Bring the log, put the 2, switch those. How many steps here I did? 1. And you still don't like it. It's up to you. Here, I did 1 step, take logs. Then taking this one out, that's another step. That's a skill in logs. Yes, we need it, but not at a level like this. And then we divide both sides by what? By log 2. That's your third step. And then I join this, another rule, and that's the fourth step. Anything wrong? No. But there's a nice rule here you can convey from me. What are these rules? That log x to the base a is always a log x. That's why I need to introduce this fact. Something else come to my mind or come from here. Log x to base y is the same as log x over log y. Whatever the base. If I want the base to be called 5, I can put 5, or I can make it c and c, or d and d, or a and a. See how many rules we have here? Sometimes you say, this is default, I know it, why should I know it as a rule? Welcome to math. You can memorize math, you can enjoy math. All right? So, gentlemen, that was example, no, actually that wasn't example, that was solving the question in another way. So I can put it like this. You can either do it that way or that way. Let's put some more examples. Mix these questions. 3 to the power, this is question 5, I believe. 2x minus 5 equals 7.5. Oh, you want to make it hard? Okay. Who cares? I have a calculator at the end of the game. This is an exponential equation. Looks scary. I want to solve it. So what do? Log. This is exponential, no log. If I want to change to log, I don't write exponent, I put log. Which is the base? The 3.1 comes here. Switch 7.5 equals. Simple. Put the 5 over there. You can put it here if you wish. You can write it like that. If you don't, you can write it like this. My advice, put a bracket, then put 5. Nothing wrong with that. Just don't put them next to each other like this. Some people think we have to add them first, so be careful. At the end, equals 2x minus, 2x, or you can put 2x here. So you have 2 options to write it. I'm in favor of writing that one, but some people don't see the difference, so I don't mind. When you finish, divide both sides by what? All of this divided by 2. Go to your calculator and just do it. Some people are afraid of doing these things. I don't know why, but it's very simple. Log, I put 3.1, I put up 7.5, I say equal, then plus 5. When I finish, I divide everything by 2. 3.39. 3.39. All right? So, where are we heading? With these basic things, I can now probably introduce some kind of function. Where is that function? I don't have any functions in here. Let me bring it from here. I know you're targeting your quiz on Sunday, not this Sunday, Sunday 31st. Let's put this function. Let's take f of x equals log x, if you wish, let's say plus 3. And if you wish, minus 2. And I can leave the base 10, or I can leave the base 4, or I can leave the base 1, maybe not. I can leave the base, whatever you wish, just put any base for God's sake. Let's make it simple. All right? How can I don't want to confuse you, but let's make sure this is not 3. Let's make it 4. 4 and 3 and 2. Because each location has something in mind. First thing, how can I find its asymptote? You remember exponential function has horizontal asymptote. This one has vertical asymptote. So if I want to find the vertical asymptote, the trick is easy. Whatever inside the bracket. What's inside the bracket? That. Take it, equal it to 0, and your asymptote is x equals negative 4. This is the vertical line. Don't say straight, it's a straight line, but vertical, like this. Number 2. What happens if I'm looking for the y-intercept? Who knows what happens? You know that, all functions have the same. So you're gonna say x equals 0. Let's go there and substitute 0. If I'm looking for y, I'm gonna take the log 0 plus 4 to the base 3 minus 2. Oops. Look for base 3 minus 2. Use the calculator. You have to. You cannot stay without it. So log 4 to base 3, and all of it minus 2. Wow, minus 7.3, blah, 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 blah. So the answer is 0.-7381. Let's say 74. So your coordinates in this case are, I said 0 for the x, and that's the y, negative 0.74. The usual thing, guess what? Number 3, how can I go for the x-intercept? And as you all know, y equals 0. So let's find out. Y equals 0 equals log x plus 4. Base what? 3. All of it must be minus 2. So as normal, you're gonna get rid of the 2. You're gonna bring it here. Some people cannot see it because they get used to my way. Yes, you can do other way, but my little advice, in order to solve this, write the log on the left hand side and put the 2 on the right hand side. Why? So I can switch this question into, you know the rule, the basic rule? You have to go back to exponential form. 3 to the power of 2 equals x plus 4. I switch those when I want to go back to exponential. I switch these when I want to go back to logarithmic. This is your baby. You cannot say, I don't like it. So 3 to the power 2 is 9. 9 minus 4 is 5. And x in this case is 5. So what's your coordinates? 5 and 0. And guess what? By doing all of this, I can sketch the curve. I can sketch the curve. Once you sketch the curve, I could ask for many other properties. So let's have the x-axis drawn. All right, gentlemen? This is your x, this is your y, this is your origin. My vertical asymptote, x equals -4, somewhere here. I don't have to say 1, 2, 3, 4, that's it. This point is -4. My coordinate there, 0, -0.7, what is that? This is the y-intercept, x equals 0. So that's the y-intercept. 0.74, negative. Is that x-intercept or y-intercept? I'm asking you. Because that is what? X-intercept 5 and 0. Where is 5 and 0? If that's 4, that's 5. So, gentlemen, this is the sketch. Smooth curve. No touching as far as you go all the way. And this will increase as you go that way. This is simply a logarithmic function. All right? So, as this goes down, as it comes smaller and smaller and smaller, -1, -2, -3, -3.5, -3.9999. What's happening? The y is going to infinity now. Okay? This comes to question number 5. Because what's now question number 4? Sketch the curve. You may have to sketch it to see it. Especially when I ask you, find the range and the domain. These are the things that you always like and you will always face. So I'm giving you an easy tool. What is the tool in here? If I'm looking for the range, I'm looking for the y. The y going all the way down and the y will go all the way up. So in that case, that's simple, straightforward. As for the domain, you can see that you need all the x's. But the x's come closer and closer to -4. It can never touch the -4. So you may say x larger than -4, or if you wish, -4 like this, and all the way to infinity. This is a very simple function. You will not need like that. This is my first video. My second video will be more examples, more facts. But without this, you just cover 80% of the material, 80% of the logarithmic functions. I can give you functions as hard as whatever I wish. I can make your function look like this. I can make your function look like whatever you wish. It doesn't matter how this looks like. The most important thing, we all know how to find the range and domain. Look at the sketch. At your level, look at the sketch. And we all know how to do the x-intercept and y-intercept. X equals 0, y equals 0, finished. And you should be able to solve. That's why I gave you the introduction. What was my introduction today? How to solve equations. How are you going to find the x-intercept? Put y equals 0. How are you going to solve logarithmic equation? Did you notice that was when I put 0 here? I am solving logarithmic equation. If I don't have the tool, how am I going to proceed the equation? So my way is showing you the basic skills of solving logarithmic equation will help me to understand what properties of the logarithmic functions. If we were in the class, I would have introduced logs in a different way. But unfortunately, time-wise, the students don't like to watch math videos. I know that, I'm not stupid. I try to keep my videos as simple as short. We started at this much 2, now 32. It's enough to have half an hour. I hope it will be uploaded. See you in video number 2.